All right, let's dive into a question that is just everywhere these days, a real battle of the titans in modern programming. We are talking about Go, Rust, and Zig. So you're a developer, right? You see these three amazing languages, and you think to yourself, which one's for me? They all seem powerful, they all have some overlap, and honestly, trying to pick one can feel pretty overwhelming.
So how do we figure this out? Well, here's the secret. The answer isn't in some giant spreadsheet comparing feature lists. That's not going to help. The real difference, the thing that will actually tell you which language clicks with you, is understanding their core philosophy, their values. Each one makes a totally different bid, a different set of trade-offs.
First up, let's talk about Go. I like to think of Go as the ultimate corporate pragmatist. I mean, it was born inside Google to solve the kind of messy problems you get when you have massive teams working on enormous software projects. And this really gets to the heart of Go's philosophy. It's all about minimalism, but for a very specific reason: collaboration. It's designed from the ground up to be simple, to be stable, to be incredibly readable. Why? So that hundreds of engineers can jump into a codebase and get productive without a huge learning curve. It's not trying to be flashy. It's trying to be good enough for pretty much everything you'd need to do. This quote just nails it. You can fit the whole language in your head. Go has very, very few features. I mean, for a long time, it famously didn't even have generics. The whole idea is that any single developer can understand the entire language, and that makes the code predictable and way easier to maintain. And that brings us to the big trade-off. On the one hand, you get a language that is ridiculously easy to learn and read. But on the other hand, that simplicity means you often have to write more code, more boilerplate, to get things done that might just be a one-liner in a different language. You're trading raw power for clarity and long-term stability. Okay, now let's completely flip the script and meet our next archetype. If Go is the minimalist, then Rust is the maximalist. It takes a totally different philosophical path, one built on the idea of absolute, undeniable correctness. Look, Rust is famously complex, right? And that complexity comes from trying to do two things that are usually at each other's throats: providing absolute, ironclad memory safety without sacrificing even a tiny bit of performance. It is an incredibly ambitious goal. To really get Rust, you have to understand its mortal enemy, undefined behavior, or UB. This is literally the stuff of nightmares for programmers. It's when your code just goes completely off the rails into some weird twilight zone where anything can happen. This is where the nastiest bugs and the scariest security exploits are born. I absolutely love this quote because it sounds so dramatic. But you know what? It's true. A program that just crashes is a gift. You know what's wrong. A program that hits undefined behavior is a ticking time bomb. And Rust is designed from its very core to prevent that entire class of errors from ever happening at compile time. And this is the price of that safety. I'm not even going to try to read this comment. Just look at it. This is a perfect example of the sheer conceptual density of Rust. To guarantee safety, the language is packed with all these concepts: traits, lifetimes, ownership, pinning, that you absolutely have to master. So yeah, that's the bargain you make with Rust. You don't just tell the computer what to do. You have to explain to its famously strict compiler how you're going to do it safely. It's a steep, steep learning curve, for sure. But the payoff is software that is provably safe in a way that very few other languages can even touch. And that brings us to our final language, the newest kid on the block, and maybe the most rebellious of the bunch: Zig. I like to call it the radical controller. You can almost think of Zig as a direct reaction against both Go and Rust. So where Go hides details to keep things simple and Rust adds complexity to make things safe, Zig's whole philosophy is to give you, the programmer, total and explicit control. Nothing happens behind your back. No magic. You are in charge of every single thing the machine does. This slide shows you exactly what that means in practice. In Zig, if you want some memory, you have to get an allocator, you have to explicitly ask for the memory, you use it, and then you have to give it back yourself. Every single byte is your responsibility. It's manual memory management, loud and proud.
And wow, the contrast here could not be clearer. In Go and Rust, the system handles a lot of memory stuff for you. You return a big data structure, and the runtime or the compiler just figures it out. In Zig, there is no figuring it out. If memory is being allocated, it's because you wrote the line of code that does it. Period.
This is why Zig has this really fun, almost subversive vibe. It trusts you completely,
It gives you all the power to do whatever you want, for better or for worse. It's a language for people who want to be as close to the metal as humanly possible, with absolutely no one looking over their shoulder. So, after looking at these three really different ways of seeing the world, we're back to our original question. But now, hopefully, it's a little less fuzzy. The choice really depends on which of these philosophies speaks to you.
And this table just lays it all out. You've got Go, the pragmatist, valuing simplicity for big teams over raw power. Then you've got Rust, the guardian, which accepts a tough learning curve as the price for guaranteed safety. And finally, Zig, the anarchist, which hands you ultimate control, but also ultimate responsibility for every single thing. So in the end, choosing between Go, Rust, and Zig isn't really just about picking a tool for a job. It's about choosing your philosophy. It's about deciding what you truly care about most when you sit down to write code. So you have to ask yourself, what kind of programmer are you?